Welcome back to The Explainer. I'm so glad you're here because today we're tackling what is honestly one of the absolute most important decisions you'll ever make for the long-term health of your reef aquarium. We're doing a total deep dive into choosing the right life support system for your tank. Specifically, the great debate: calcium reactors versus two-part dosing. If you want your corals to absolutely thrive, you gotta get this right. And today, we're gonna take all this complex chemistry and make it incredibly clear.
Okay, let's dive into this. Which method actually fits your reef? I really want you to keep this question in the back of your mind as we go through today's explainer. Both of these approaches, they can work exceptionally well, but they're built for entirely different systems and, let's be real, entirely different lifestyles. To find your perfect answer, you're going to need to look at your tank's specific chemical demands and maybe even more importantly, your personal maintenance habits. Are you the kind of person who loves to tinker and tune equipment, or do you just want straightforward routine measurements?
To help you figure that out, here's our roadmap for today. First, we'll look at keeping reef chemistry stable. Then we'll break down how each method works, followed by a showdown of stability, maintenance, and cost. After that, we'll help you find your perfect fit, talk about safety and troubleshooting, and wrap it all up with the bottom line. Let's get to it. Section 1. Keeping reef chemistry stable, the core problem. Because before we start comparing any gear, we really have to understand the foundational issue we're actually trying to solve here.
The absolute ultimate goal of both of these methods is to prevent slow chemistry drift. Think of your reef tank kind of like a leaky bucket, right? Your corals, your clams, even the sand bed, they're constantly consuming calcium and alkalinity to build out their skeletons. If you aren't actively replacing what's being consumed, your water chemistry is just going to slowly drift right out of that safe zone. So both a calcium reactor and a two-part dosing system are ultimately trying to solve that exact same problem. They just go about maintaining that stable calcium and alkalinity in completely different ways.
Moving on to Section 2. How each method works, the mechanics. Time to look under the hood.
Let's move to and see how this builds, starting with the three-step mechanical process of a calcium reactor. Step 1, the system uses CO2 to essentially create a highly controlled, acidic environment. This dissolves the media inside a chamber, which is typically aragonite, basically just crushed coral skeletons. Step 2. As that media melts away, it naturally releases perfectly balanced calcium and carbonate. Step 3. This whole process creates a controlled effluent. That's a nutrient-rich liquid that drips continuously, right back into your tank. The real beauty of this process? Alkalinity and pH are managed as an integrated part of this continuous breakdown.
Now, contrast that continuous integrated breakdown with two-part dosing. This method involves adding calcium and alkalinity as completely separate liquid solutions. And you might be wondering, why separate? Well, if you mix them together in a highly concentrated form, they instantly precipitate. They basically turn into a useless chemical snowstorm. No one wants that. So instead, you use automated pumps to inject these liquids separately into the water over time. You just measure your tank's consumption or use calculated estimates, and the pumps replenish exactly what was used. It's an incredibly straightforward method of simple, direct replacement.
Which brings us to Section 3, stability, maintenance, and cost, the showdown. Let's put these systems head-to-head across those three major pillars of aquarium management.
Now, what's really interesting about this comparison is that both methods can achieve totally perfect stability, but they demand entirely different types of maintenance from you. With a calcium reactor, you get this beautifully continuous, steady input, but your maintenance involves some actual hands-on wrenching, You're checking CO2 regulators and periodically refilling heavy media chambers. Two-part dosing, on the other hand, gives you incredible consistency through calibrated pumps. The trade-off there is that you're going to be frequently mixing up new batches of liquid reagents and constantly refilling those containers, especially as your corals grow and consume more.
When we look at that third pillar, cost, there honestly isn't a single right answer. The true financial winner depends a lot on your local prices for CO2 gas versus bulk chemical reagents. Generally speaking, small to medium tanks find two-part dosing to be incredibly economical. But if you have a massive tank that's just packed to the brim with fast-growing stony corals, the sheer volume of daily liquid you'd need to dose makes the raw efficiency of a calcium reactor the much cheaper long-term option.
All right, Section 4, finding your perfect fit, the decision matrix. We know the trade-offs, so let's match the gear to your actual lifestyle. And this brilliantly illustrates exactly how you make your choice. First up, consider your tank size. Larger, heavy demand systems definitely lean toward reactors, while smaller or mixed reefs absolutely thrive on two-part dosing. Next, think about your daily preferences.
Do you prefer the mechanical, physical tuning of a CO2 regulator, or are you more of a tap a few buttons on an app to change a pump's schedule kind of person? Finally, take a look inside your aquarium stand. Do you actually have the physical space and plumbing for a bulky reactor chamber and a heavy gas cylinder? Because if you don't, two-part dosing offers a vastly simpler, space-saving footprint.
Section 5. Safety and troubleshooting. Mitigating risks. Because whichever system you ultimately select, chemical accuracy is literally a matter of life and death for your corals. Both of these methods carry totally unique risks that you absolutely need to take seriously. With a calcium reactor, improper CO2 tuning can plummet your effluent pH, either melting your media way too fast or stalling the whole process entirely. With two-part dosing, a failed pump calibration can cause a massive chemical overshoot, while weak, improperly mixed reagents can slowly, silently starve your corals. So what's the ultimate safety net for both? Catching the drift early. Consistent weekly testing and diligent logging of your alkalinity and calcium are completely non-negotiable if you want to prevent stressing out those sensitive corals. And that brings us to Section 6, the bottom line, your final choice. Let's distill all this technical detail down into one clear, actionable takeaway.
So the crucial point is this: the right method is the one you can run consistently. Let that sink in. Either approach will grow beautiful, thriving corals, because at the end of the day, the gear doesn't dictate your success, your personal habits do. If you want automated, continuous replenishment and you don't mind tuning a reactor, go with calcium. If you want easy scaling and super straightforward, flexible adjustments, go with two-part. You just have to pick the one that matches your willingness to actually test, calibrate, and maintain it week in and week out.
So, I'll leave you with this final thought. Which system truly matches your willingness to maintain? Be brutally honest with yourself about your reef tank goals and your everyday habits. Take a look at your aquarium today. Evaluate your space, evaluate your routine, and make the choice that will set you and your corals up for long-term success. Thanks so much for joining me on this deep dive, and I will see you on the next explainer.